This is an easy one since there's a 1 in front of the x squared. Got negative 24. So what two numbers multiply to give me negative 24 but add up to 2? So let's see, how about 6, negative 6 and positive 4? So I'm going to go x minus 6, x plus 4 is equal to 0. So my answers are x equals 6, x equals negative 4. All right, so what answer is that? Should be letter B for that one. All right, now the next method is extracting square roots. Now this is probably one of the easier methods because they're going to give you something like this. They're going to say x squared is equal to 16. Well, you're not going to factor this. You're just going to say, oh, since you don't have a middle term, this one always works if you don't have a middle term like a 3x or a 4x. If you don't have an x term, it always works. So I would just take the square root of both sides. I'd end up with x equals plus or minus 4. Now why plus or minus? Because when you take the square root of a number, you get positive or negative. Now let's say I had something like x squared minus 10 is equal to, let's say, I want this to work out, so let's say 15, okay? We can still solve this using square roots. I would just add 10 to both sides. You want to get the x squared by itself. So then we'd end up with x squared equals 25. Now I take the square root of both sides, so x equals plus or minus 5. So that's the gist of this type of problem, extracting square roots. So consider the quadratic equation in the form u squared equals 16, where d is greater than 0 and u is an algebraic expression. Then we can just take the square root of both sides. When we take the square root of both sides, we get plus or minus. That's why we have two solutions to this. Now, if we have problems like this, you want to get the x squared by itself. Okay, so the first thing I would do here is I would divide through by 4. So I'd end up with x squared is equal to 3. I can still take the square root. Now, it's not going to be real nice, but I'm going to end up with x equals plus or minus the square root of 3. That's a legitimate answer. Okay. Here, a lot of kids, they really mess up here because this parenthesis is squared. So yeah, the square is by itself on one side. So I can take the square root of both sides. So this becomes x minus 3 is equal to positive square root of 7. And I also have x minus 3 is equal to negative, that better be a 7, square root of 7. And now I would add that 3 to both sides. So x equals positive square root of 7 plus 3. Or I'd add x equals negative square root of 7 plus 3. Okay, so if it's in parentheses, you can still take the square root of both sides. It does work. Now, the next method is called completing the square. So I'm sure all of you have seen this before. So let's say I gave you a problem like, let's go x squared plus 10x plus 20. And I asked you to solve this by completing the square. Okay? I always told kids to get the constant on the other side. And some teachers don't teach that way. And then I always tell kids, you're going to add something. So then I end up with negative 20 over here, right? And then I'm going to add something over here. So whatever I add to this side, I'm going to add to this side. What am I going to add to both sides? Well, you take half of the middle term. So half of 10 is 5, and you square that. So I'm going to add 25 here. I'm going to add 25 here. So now on this side, this is what is called a perfect trinomial square. It factors down to x plus 5, x plus 5. But I don't want to write it that way. I want to write it this way. Is equal to negative 20 plus 25, which is 5. Now it looks like that last problem that we did. I could take the square root of both sides. So I end up with x plus 5 is equal to positive square root of 5. And x plus 5 is equal to negative square root of 5. Subtract 5 from both sides. So x equals positive square root of 5 minus 5. And subtract 5 over here. So I get x equals negative square root of 5 minus 5. Oh, that's completing the square. Love completing the square. All right, so let's try another example. It says you can do this method called completing the square. When you complete the square, what you're doing is you're taking half of the middle term, so half of the b, and you're squaring it. And that's what you're going to add to both sides. Okay, so let's try another one. Solve by completing the square. So I've got x squared plus 2x. I'm going to add that 6 over to this side. So I'm going to go plus something is equal to positive 6 plus something. Why did I put plus something here, plus something here? Because I'm going to add something here, and if I add it here, I have to add it here. That's the only way to keep the sides equal. Half of 2 is 1, 1 squared is 1, so I'm going to add 1. Well, it's not much. And then if I factor this, it becomes x plus 1 times x plus 1, but that is not how I want to write it. I want to write it this way. And 6 plus 1 is just 7. So now I take the square root of both sides, and I end up with x plus 1 is equal to the square root of 7, and x plus 1 is equal to negative square root of 7. Then I just subtract 1 off. So I get square root of 7 minus 1, negative square root of 7 minus 1. Done. That is completing the square. When the leading coefficient is not 1, you must divide each side of the equation by the leading coefficient before completing the square. So for example, if I had something like 3x squared plus 9x minus 15 is equal to 0. Yeah, I'd bring the 15 over here, so I've got 3x squared plus 9x plus something is equal to 15 plus something. You've got to divide everything by 3. Okay, you just have to. You can't get away with it. So now I have x squared plus 3x plus something is equal to 5 plus something, and then you can complete your problem. So you can't complete the square if there's a number out in front that is not a 1. Okay, so you always want to make that a 1. All right, here's a problem off this week's practice. It says, what goes in this box? Half of 12 is 6. 6 squared is 36. So that's what I would add if I was completing the square. In this problem, it says, solve by completing the square. Okay, I've got x squared plus 10x plus something is equal to 39 plus something. Half of 10 is 5. 5 squared is 25. So I'm going to add 25. I'm going to subtract off 25. So this gives me x plus 5 quantity squared is equal to, what is that, 64? Oh, that's nice. Why is it nice? Because when I take the square root of both sides, I'm going to end up with x plus 5 is equal to plus or minus 8. So if I subtract off 5 from 8, I get 3. If I subtract off 5 from negative 8, I get negative 13. So that should be my answer, letter A. So those are 3 different ways to solve a quadratic. I know, as I said, this would take me, probably 4 weeks in my Algebra 2 class. But in pre-college, fly right through this. But remember, if you have, time on Monday, and if there's something you don't understand, please, if there's one of these methods, please come to the session and we'll go through as many questions as you want. Now, the last method of solving a quadratic, which always works, quadratic formula. The quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. You guys should have this memorized by now. You've learned it in Algebra 1. You learned it in Algebra 2. I'm sure you had it in pre-calc. Now, some of you didn't take pre-calc. So you should have learned this before. This is the one method that always works when solving a quadratic. Okay. Now, the discriminant is just the part inside the radical. So if they ever ask you what is the discriminant, it's just the b squared minus 4ac. It's the number that you get when you do the radical, and it just tells you how many solutions you have. Not too many times will you be asked what the discriminant is, but if the discriminant is positive, you have 2 real solutions. If the discriminant is 0, you have 1 real solution. And if the discriminant was a negative number, if you ended up with the square root of like negative 10, there are no real solutions. That doesn't mean there's no solutions. It just means they're not real. They're going to be, you can have imaginary solutions, right? We haven't talked about imaginary numbers yet in pre-college, but you should have in Algebra 2. We will definitely talk about imaginary numbers in pre-college, no question about it. So if I asked you to solve this problem, x squared plus 3x is equal to 9. No, first thing we have to do is we have to set it equal to 0. So x squared plus 3x minus 9 is equal to 0. So my a value is 1. My b value is 3. My c value is negative 9. So I'm going to use the quadratic formula. X is equal to negative b, so that's negative 3, plus or minus the square root of b squared, so 3 squared is 9, minus 4 times a times c, so that's negative 36, all over 2a. 2 times a is 2. So if I work that out, 9 plus 36, that's 45, so I got negative 3, plus or minus the square root of 45 over 2. And I would stop right there. Because, could I simplify the square root of 45 down? Sure. I could rewrite this as a square root of 9 times the square root of 5, which is 3 square root of 5. Could do that. Okay, so I could rewrite this as negative 3 plus or minus 3 square root of 5 over 2. That would be a much more simplified answer, but I would accept this. Here's a problem on our practice. Got 3x squared, so I'm going to rewrite this as 3x squared minus 5x minus 8 is equal to 0. Remember, whenever you're solving a quadratic, you always want to set it equal to 0. It's the only way that you can solve. Okay, so in this problem, my a value is 3, my b value is negative 5, my c value is negative 8. All right, so negative 5, because it's negative b, remember, so that's going to be 5 plus or minus the square root of b squared. Well, negative 5 squared is 25. Minus 4 times a times c. So what is that? 12. That's negative. So 12 times 8, that's 96. So negative 96. All over 2 times a, which is 2 times 3, which is 6. All right. So now I have 96 plus 25 for my discriminant. So that's 121. I like it. Why do I like it? Because this is going to be 5 plus or minus the square root of 121 over 6. 121 is 11, right? The square root of it. So this is going to be 5 plus 11 over 6, or 5 minus 11 over 6. 5 plus 11 is 16 over 6. So that's one of my solutions. And 5 minus 11, what is that? 6 over, that's negative 6. It's going to be negative 6 over 6. So one of my answers is negative 1. My other answer, if I simplify this, 8 over 3. So 8 thirds and negative 1. Letter B.